Well, the first thing that you normally talk about in calculus is the definition of the limit. However, this is pretty abstract for most, and I know it was really abstract for me when I first seen this. And if you're learning calculus for the first time and you haven't done anything with limits, I would suggest that you first go to the section finding limits numerically and then come back here. As a matter of fact, probably even be better yet that you even looked at the graphical discussion on limits and maybe even finding limits analytically, and then come back to this section here. But that's my opinion. Okay, well, if you've never seen this before, this is going to be a new concept for you, and like I said, it's kind of hard to grasp at first because of all these abstract symbols and this crazy looking notation. But this is one of the most essential things in calculus. This is pretty much what builds all of calculus, and that's this idea of the limit. But let me just go through, read this definition here. We're going to let f be a function defined on an open interval containing c, except possibly at c, and let L be a real number. The statement, the limit of f of x as x approaches c is equal to L. Now, there's another way of saying this, and that's the, of course, the much more abstract looking way. This upside down A here means for all epsilon greater than 0, there exists a delta greater than 0. That means there exists a delta greater than 0 such that if we have the absolute value of x minus c is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. Let's take a look at a graph and what I mean by this. Okay, so it was x minus c, remember, and it was the absolute value. Now we're going to unravel that here in just a second, but this is what we're kind of looking at here. And you evaluate a function at c and you get L out. However, we're not evaluating a function at c. What we're doing is we're taking the limit as x approaches c, and it's equal to some real number L up here. Now, really kind of what's important here is I think I've kind of exaggerated this, but this distance right here, you can see is a little bit smaller than this distance here. And so this delta is going to be the delta that we choose. Now, it's c plus some number, right, gets us to here. And this is going to be really important that we choose this delta here. If I end up choosing this delta, that means that I would come out to about here. And if I pick some number x inside of this interval from here to c, for example, let's say I picked an x value that happens to be, let's say, right in here, just on the left side of our c plus delta, that would be the red delta, then there is no f of x value that's inside of this interval here. Okay, so when we choose an x, it must be inside of this interval here, inside of this interval here. Alright, so that's pretty important. But the way you can also see this is f of x gets close to L. Alright, that means that there's some x inside of this interval here that's getting close to c. But let's unravel that definition. So this is our absolute value. It can be rewritten as x minus c less than delta, x minus c greater than delta, and what I'm doing here is solving for x, as you can see, in both sides. And so we got x is greater than this and x is less than c plus delta, but that can be rewritten as an interval. And of course I'm doing the same thing here, just unraveling the definition.